that I'm going to show you is that the derivative of the sine is the cosine, and then the derivative of the cosine is negative sine x, and where they come from. So we're going to kind of go through and develop the derivatives of all 6 of the trig functions then. Okay, now let me just go over this one more time. So if we're doing the derivative of the sine x, and you've already got this written down. I think I made a mistake at the end of the class on this, so I just want to get this one more time. So we're going to go limit h goes to 0. Okay, then of course we do f of x plus h, which would be sine of x plus h. Okay, then minus sine x all over h like that. Okay, so this formula, of course, is what gives you the derivative for everything. Okay, so what we talked about, and you're going to have to kind of pull out identities a lot of times in trig. So we talked about, like you learned in trig, hopefully you remember, the sine of a plus b. Okay, and that's the one that goes like this. It goes sine a, cosine b, and then it goes backwards. Cosine a, sine b, and then there's a same sign like that. So I always think of that as sine, cosine, cosine, sine, same sign. Okay, so what we're going to do is we're going to take this thing, and we're going to use the identity to do that. And then we're going to pull out those 2 limits, I think, that we talked about a little bit last time. So when I do this now, I'm going to have limit h goes to 0. Now I'm going to apply this identity. So when I do what I highlighted there, you're going to have sine of first, cosine of second, same sign, and then cosine of first, and then sine of second like that, minus sine x over h. Okay, so we never would have really figured out what the derivative of the sine and cosine is without those 2 limits that we developed by the squeezing theorem as the idea. So what I'm going to do is I'm actually going to group these 2 things together. I'm going to put this together with this, and I'm actually going to break it up into 2 limits. So what I'm going to say is limit h goes to 0, and then I'm going to write down sine x cosine h minus sine x over h. Okay, I can group those together however I want to. And then we also learned that if you have a limit of a sum, you can break it up into the sum of the 2 limits. So I'm going to write this now as another limit. So I'm going to say limit h goes to 0 of cosine x sine h like that. That's all valid things that we've learned how to do. Does that look okay so far? That seem reasonable enough? Okay. What's that? Oh, I got to put that over h. So yeah, you're right. That isn't very reasonable. Okay, we got that. Okay. All right. Now, on this, you can factor out a sign. So you've got a common factor of a sign that you pull out, and then you'll kind of see where I'm going with this, hopefully, anyway. So I'm going to pull out that sign, so I'm going to have limit h goes to 0 of sine x, and when I take that common factor out, I'm going to have cosine h minus 1 all over h like that, and then I'm going to bring this down. And then we're almost ready to start kind of looking at what these limits are, okay? So what you want to look at on this is basically, since we're looking at the variable h, this sine of x can be thought of as a constant because it doesn't have anything to do with h. It's a different variable. So that thing can actually be brought out of that limit like any constant can. You can think of that as a constant. And then same thing here, the cosine of x can be thought of as a constant because it's a different variable. We're not doing the limit as x goes to 0, we're doing the limit as h goes to 0. So what you can do is you can write this then as sine x times the limit as h goes to 0, and with the sign going out, you're going to end up with cosine h minus 1 over h. That's the limit we talked about in class. And we kind of developed that with a calculator, and we looked at the squeezing theorem. Then when you pull the cosine x out of here, you would have cosine x times the limit as h goes to 0 of sine h over h like that. Okay? Now, this is what we learned last time, basically. We did this limit right here. We developed that limit. And then we developed this limit right here. And it turned out, if you kind of look back in your notes, that this thing right here, we found that that was 0. Okay, we worked that out with the squeezing theorem. And this one we worked out that was 1. like that, okay? So if you put this all together, what you have now is you have sine x times 0 plus cosine x, that whole limit's 1, that's going to cross out, so you get the cosine of x. So what did I just show you? I just proved to you that the derivative of the sine is the cosine, okay? And that's pretty cool that it turns out to be that simple. So when you're finding a slope of a tangent line on a sine wave, it ends up to be the cosine wave, okay? Those waves, of course, are very similar to each other. They're just phase shifts of each other, so that's the development of that, okay? Does that make sense? Do you guys follow that okay? Kind of what I did, okay? I don't have you reproduce that, but I like you to begin to see at this level of a class some proofs and where they come from. What you're going to be required to know mostly is, of course, how to do the differentiation of the trig functions and then the applications that I'm going to be teaching you, okay? So I'm going to run to the next page now, and we're going to do the same thing with the cosine. Now, we're only going to do the cosine with the limit. It'll turn out the other 4 trig functions, we won't really have to do this difference quotient anymore to develop them. So that's what we're going to work on a little bit here then. Okay, so next thing you want to know is the derivative of the cosine's negative sine x. Okay, so let's go ahead and let's do a proof on that. Okay, so when we do the derivative of the cosine, first thing that you need to do is you need to set that up in, of course, the difference quotient. So the difference quotient goes limit h goes to 0, and then you're going to do f of x plus h minus f of x all over x. Well, what is f of x plus h going to be? It's going to be cosine of x plus h, right? All you're doing is replacing that x with x plus h. So that's going to be cosine x plus h. Then the function is cosine x, and then that's all going to be over h like that. So we're going to work out that limit. So what you have to pull out of this is you got to pull out this identity. So you learned this in a trig class, hopefully. If you have cosine of a plus b, that's the one that goes like this. That's the one that goes cosine of first times cosine of second. Then you do the sine of the first times the sine of the second, and then the sine is opposite like that. Okay, that's how a cosine sum identity goes. You just do cosine, cosine, sine, sine with different sign, like that, okay? So what I'm going to do, as I'm doing this proof, is I'm going to go ahead and work this out, and we're going to kind of go through the basic same logic here and see what happens, okay? All right, so let's see if we can get this kind of put together here then, okay? I'm going to replace what I highlighted with the identity. So that's going to go cosine x times cosine h, different sign, minus, then we're going to go sine x times sine h, and then that's all going to be over h. I'm going to go ahead and just kind of put this all together like that, okay? So identities, we just pull out identities. We have to know, math kind of builds on itself, so the trig identities are going to be used to develop other theorems and so forth a lot of times. Okay, now what I'm going to do on this is when I put this together, I'm going to group this together in a real similar way to what I did on the last problem. So I'm actually going to group these two things together and then kind of put that other piece of that to the side like that. So it's actually very similar to the problem I just did. So what I'll have you do is let's write this as limit as h goes to 0 of cosine x times cosine h minus cosine x all over h. Of course, I can break this limit of a sum and difference into a difference of the limits. So I'm putting those together. Then I'm going to write minus and then a new limit h goes to 0 of sine x times sine h all over h like that. Okay? You guys follow what I'm doing so far? Algebraically? All I'm really doing is I've applied one identity, and then I'm just using a limit theorem that we've learned how to do to kind of put this together, okay? Let me see if you guys see where I'm going with this now. Any suggestion about what I could do to the algebra on this expression right here? There you go, take out a cosine. Okay, good. Okay, so we're going to do that. So it works out real similar to the one we just did. So what you would say is limit h goes to 0. Now you would say cosine x times cosine h minus 1 over h. Okay, there's a reason why we're doing this. And then I'm just going to bring this down, and then you'll hopefully kind of see where I'm going with this. Okay. All right, now here's what you really want to see in this problem is this. Okay, we talked about these limits right here. We did that limit last class, and we also did this limit right here. So we know what those limits are. And what you can end up doing then is, like on the last problem, see, the cosine of x can be thought of as a constant because it's a different variable. We're not taking the limit as x goes to 0, so that can be pulled out. Same thing over here, the sine x can be pulled out. So you write this then as cosine x times the limit, h goes to 0, cosine h minus 1 over h. See, the limit theorems, if you don't know the limit theorems, you could never figure this out. So it's a fundamental part of this. And then same thing here, bring the sine out. Then you would have limit h goes to 0, sine h over h like that. Okay? All right, now what we found out is we found out that this limit right here, that was equal to 0. That's the one that was equal to 0. This limit right here, that's the one that we found out was equal to 1. So look what we have. We have cosine times 0 minus, and then we have sine x times 1. So that's going to give 0. That gives negative sine x. Voila. Proved. Isn't that slick? Okay. All right. So that's kind of how that goes. Again, I don't have you guys reproduce that, but if you feel like you kind of get the gist of how that's going, then that's helpful to you as you proceed and go through some other math classes, particularly if you're going to go look kind of more at the theory of this stuff. Okay. Any questions on that? Okay, does that look reasonably good? Okay, all right, we spent a lot of time on doing these two limits like right there. We did squeezing theorem, and then we just kind of looked at those two on the calculator, okay? Now, what we're going to do on the next page is we're going to go ahead and I'm going to develop the rest of these. So that would be the derivative of the sine and cosine. And you want to get these things memorized as fast as you can, okay? Derivative of sine is cosine. Derivative of cosine is negative sine. That's what you're going to try to get out of that, is make sure you know that rule. Okay, now I put this diagram on here and wanted to kind of show you this. Basically, in this particular problem, the cosine, this is the cosine and this is the sine, okay, like this. So what I've done on this is the cosine, of course, is the graph in blue. And then the derivative of that, we just figured out that the derivative, y prime, is equal to negative sine x. So I want to see if this makes any sense to you. All right. First of all, at this point right here, the value of the derivative would be 0, right? Because it's the slope of a tangent line. I want you to notice, if you graphed negative sine x, well, it's got a y value of 0. That's the first thing I want you to see, okay? Now, if you go through like this, if you look at this part of the graph right here, aren't the tangent lines at this part going to be negative? They're going to have negative slopes, right? Notice that all of these values right here are negative, aren't they? Okay? And actually what's happening is you start off real steep, and then you get less steep. And then again, what happens here is the value of the derivative would be 0, right? Well, what's the value of the y equals negative sine x? It's 0, okay? Now notice, right here you would have positive tangent lines, wouldn't you? Okay, if you're right here, the function's increasing, so you have positive tangent lines. So from here to here, notice that all of those values right there are positive y values. So what we've talked about with graph of derivatives, hopefully you can kind of make some sense out of that. Does that look any good or not? Okay. Now I want to pull up one thing just on my math lab. I think I put this on here. Then I'll go back to where I was. That says graph of derivative apple. No, it says applet. Okay, so I put this on here for you to play around with a little bit. And what I think is kind of cool about this is you can look at all kinds of different let me squeeze this over here like this. Okay, you can look at different examples and stuff like this. So it has several different demo examples, so you can kind of look at different things. I was going to see if they had a sine or cosine. Okay, so this one right here is basically, which one? Is that sine or cosine? Probably. Okay, that's the sine. So what this does is if you take this slider, what it's going to be doing is it's going to graph the derivative. Okay, so right now, what's happening is we have a negative sloping tangent line on the red graph. Now it goes to 0. Why does it go to 0? Because at that point, the tangent line's 0, right? Now you're going to have positive tangent lines, right? So notice that the graph is above. Now why does it go to 0? Because the tangent line's horizontal like that. Okay, so that's how that goes. Okay, so you can kind of use this to kind of help you visualize how derivatives go. So notice that what I graphed on that looks a lot like the cosine wave, doesn't it? Okay, now this didn't tell me specifically what that was, but it gives you a rough idea. And you can kind of play with this with different examples, and I think it's a pretty helpful thing to look at as you're doing that then. Okay, so let me go back to where I was here. And let's go ahead. Now we're going to do some basic derivatives here. Okay. All right. So we're going to do the derivative of all these functions now. And see, all we know right now is we know this. We know the derivative of the sine of x is equal to cosine x. So as we're doing these problems, we're going to pay attention to that. And we also know the derivative of the cosine x is negative sine x. Another derivative rule that we learned is this. This is the easiest one to remember. What's the derivative of e to the x? E to the x. Okay, I like that one. Okay. All right. Then we also learned this last time. If you had the derivative of e to the kx, you remember what that one was? K times e to the kx. Okay. That rule will actually make a little bit more sense next week when we start learning what's called the chain rule. Okay, so on this example one, we're going to go ahead and find the derivative. And, I like to try to get students to write steps a certain way. But what we're doing on this, since we're doing a derivative of a sum, we learned that really what we're doing is the sum of the derivatives. And I would like you to write that down there because I want to emphasize that derivative rule that we learned. So this one is actually going to be very simple. All right, so the derivative of the sine, what was that? Cosine. What was the derivative of the cosine? Negative sine. Okay. So then just write this answer as cosine of x minus sine of x. So that would be what your derivative is. That's a real simple one right there. Okay. All right. But the idea is if you're doing a derivative of a sum, we know and have learned that you can do the sum of the derivatives. Okay. Now, example 2. You have two functions that are being multiplied. So how do you think I should take care of this one? The product rule. Good. Okay. So when you do the product rule that we learned last time, memorize the product rule in words. It's the first function times the derivative of the second plus the second function times derivative of first. Real easy to remember. First s prime plus f prime, like that. So when we put this together, we're going to go like this. And again, I like to use this Leibniz notation is what I like to do. So I just write down the first. The first is e to the x. Don't touch it, just write it down. Multiply that by the derivative of the second, which is now what we just learned. Now do plus, now do it backwards. The second function is sine x, and then multiply that by derivative of first. Okay, a lot of times students want to be kind of lazy and don't want to write that out. I prefer that you write that step out. Okay, so that you're really focusing on the terminology with the Leibniz notation. Okay, so this is e to the x. Okay, what is the derivative of the sine then? Cosine. And then what's the derivative of e to the x? E to the x, that's it. Okay, so this is not going to be too hard of a derivative either. So derivative of sine is cosine. Okay, bring down the sine of x, and then the derivative of e to the x is what? E to the x, okay? Now that's really a derivative. I mean, you could write the answer that way. What I like to try to get students in the habit of doing for things that we're going to do later is factor if you can. Can you factor that? Yeah, you can take an e to the x out, right? Okay, it's a good habit to do that. Now, there's nothing wrong with leaving the answer this way. I mean, that's fine. But just kind of, if you see something that factors, I think it's a good idea to now factor, because that's going to be something that we're going to be doing a lot when we get to the next chapter. So that would be your derivative like that, okay? So that's product rule. You got to know that since it's a product of two functions, that you have to use the product rule. Okay, how's that look? Okay, all right, if you know the product rule, those are actually pretty easy derivatives. They get a little harder, of course. Okay, what kind of rule do you think you'd use on example 3? Product rule again. Okay, this is like your first function is e to the 6x. Your second function is cosine x. So again, I'm going to do dy dx, which means I'm finding the derivative of y with respect to the variable x. Product rule says write the first, multiply that by the derivative of the second, and just write it down before you start doing the derivatives. Then plus, write down the second, and then multiply that by the derivative of the first, like that. Okay, so what we need to do is we got to focus on two of those derivatives, this derivative, and after we do that, we just need to see if there's any algebra I can do that'll clean this up a little bit. Okay, so that's going to be e to the 6x. What's the derivative of the cosine? Okay, negative sine x. Okay, then bring down the cosine. What's the derivative of e to the 6x? 6e to the 6x. Good. Okay, like that. Okay, so just applying all those rules like that. Now again, clean it up and see if there's anything. What I'm going to do is put that negative in front, writing that as negative e to the 6x sine x plus 6 e to the 6x cosine x. Any factoring, you see? Take out a common factor. If you got a common factor, go ahead and just take it out. You can kind of develop the habit of looking for that in these problems. Okay, so what I can go ahead and do is I could go ahead and just take that out. Then when I do that, I would have e to the 6x. And then after you take that out, you'd be left with negative sine x. And then take that out plus 6 cosine x. And that's okay to write the answer that way. There's not a thing wrong. There's really nothing wrong with writing that as the answer or that as the answer. Probably the most likely way you would see this written in a textbook would be like this. It's just kind of a matter of preference. It's not necessary. I don't know. It's just kind of we like to write stuff that way more than having a negative. Okay, so that would be, to me, the way to write the answer. Although, if you're doing a test or something, it doesn't matter. Any of those three are okay. All right. Okay, how's that look? Okay, all right. Okay, now this one, we're doing the derivative of y equals sine squared x. We have not learned the chain rule yet. We're going to learn that next week. So really, all you could do on this problem at this stage is, since it's a sine squared, is to write it out like that. That's all you could do at this stage. Now, when we get to the chain rule next week, we'll be able to do this problem just, in our head pretty much, very quickly. All right, now what are you going to use on this? Product rule again. Okay, you got the first and the second, and it doesn't matter that they're the same thing. You're still going to treat this the same way. So when you do dy over dx, you're going to write down the first function, which is sine x. Then you're going to multiply by the derivative of the second, like that. Then we're going to do it backwards. Okay, if we do it backwards, we write down the second, and then we multiply by the derivative of the first, like that. Okay, so it's first times derivative of second plus second times derivative of first. Now what we need to do is do those two derivatives, clean it up every now and then, and what happens a lot of times on trig things is you have to pull out identities to simplify it. All right, what's the derivative of the sine? Cosine. Okay, so you'd have sine cosine there, you'd have sine cosine there. So is there anything else you could do? Aren't those like terms? Okay, don't you have two of them? Okay, so you'd write the best way to write the answer is those are like terms. 1 plus 1 would be 2 sine x cosine x, like that. Okay, now I don't know if you guys remember this or not. I'll ask and see. There is an identity that has 2 sine x cosine x in it. Does anybody remember what that is? Sine of what? Yeah, there you go. Okay, now that's an okay answer, but in trig you probably learned the identity sine 2x equals 2 sine x cosine x. Okay, so you could also write it as sine 2x if you want to. They're the same. You don't have to, but it's kind of good when you're working with these trig derivatives to pull out some of your identities and look for them. Okay, so one thing I probably should do is pass out an identity sheet. You guys could also go to Google and Google trig identities, and you find all kinds of stuff out there, so it's probably a good thing to have as you're doing some of these problems. Okay, any questions about anything? This stuff's fun, don't you think? Well, I think it is. I could just do derivatives all day. Okay, any questions about any of that? Okay, I'm going to let you guys work on just the next two. I'll put this back up here if any of you need to copy that down. But go to the next page and take a few minutes to work out the next two. See if you can do that. Okay, these are product rules. So the first one, you should have just done the product rule. Okay, and when you do this, you're going to write down the first. Don't do anything with it, just write it down. Then you're going to multiply by the derivative of the second, and then plus the second times the derivative of the first. So the first step is always, if you got a product rule, just get it set up. Okay, now we'll see what comes out of this then. Okay, so this is x squared. So what was the derivative of the sine x? Cosine x, okay. Then bring down the sine x. And what's the derivative of x squared? 2x, good. Okay, so you have that. That's your derivative right there. Now all I'm going to do is just clean this up a little bit and write this as x squared cosine x. It's a good idea to put the 2x in front of that. And see, this is also an okay answer. That's okay. But do you see any factoring you can do? What comes out? X, okay? You have an x squared and you have an x. You take the one with the lowest exponent out. So you want to probably go this far to prepare you for what we're going to be doing. So this is going to be x cosine x there. And then this is going to be 2 sine x, like that. And then just make sure if you do a distributive property that checks out and everything like that, okay? So that would be as far as I'd want you to go with that, is try to do the factoring like that then, okay? So that's product rule. All right, how do you approach number 2? Write it out twice and use the product rule. Just like I did the sine squared a few minutes ago, it's the same idea, okay? So when I do the derivative dy dx, what I do is I write the first, like that. Then I multiply by the derivative of the second. Then I do it backwards. I write the second, and I multiply it by the derivative of the first. You're really kind of doing on this one the same thing twice, so you do that. Okay, let's see what we get here. All right, what was the derivative of the cosine? Negative sine x, so that's going to be replaced with times negative sine x. Okay, cosine x, and again, this is going to be times negative sine x, like that. Okay, so what we're going to end up with this is I'm going to write this as negative cosine x sine x, and then I'm going to write this as minus cosine x sine x, like that. Well, what can you do with this? Those are like terms, aren't they? So how many do you have? You have 2 of them. Now I'm going to write it this way. Put the sine x cosine x, like that. Now we learned in trigonometry there's the identity that says sine 2x equals 2 sine x cosine x, like that. Okay, so you could actually write the answer that way, or you could just say, okay, this part right here that I'm boxing in, that's the sine of 2x, so the best answer would be negative sine of 2x. Okay, that's using the identity. You can write the answer either way, but again, it's good to see that identities can sometimes simplify these a little bit like that. Okay, so that would be the final answer, is negative sine 2x. Okay, and again, that's a problem that next week we'll learn how to do that with the chain rule, and it's actually a little easier when you do that with the chain rule. Okay, all right, is there any questions on those two? Okay, I'm going to do a couple of more on this page, and before we start going on and doing the rest of these. So if you're doing example 1, what kind of rule do you have to use? You got to use the quotient rule. This is a quotient, okay, where remember you have a fraction, so I'm going to say t is the top in this quotient rule formula and b is the bottom. So it's a quotient, okay, it's a fraction. So what you have to do is use the quotient rule. So you want to go ahead and get it set up. So you start this way on the quotient rule. It goes bottom times derivative of top minus top times derivative of bottom over bottom squared. So we're going to write down the bottom, 1 plus sine x, and then we're going to multiply by the derivative of the top. So I'm just going to put d dx 1 minus sine x, like that. Okay. Then I'm going to do it backwards. It's minus the top, which is 1 minus sine x. Then I'm going to multiply that by the derivative of the bottom. Okay, then it's going to be all over the bottom squared, like that. Let me take off this big line there. Okay. Okay, so that's going to be all over the bottom squared. You're going to find that the quotient rule a lot of times can get a little messy with algebra. So we got everything set up in the quotient rule, okay? Now we got to do 2 derivatives, then we got to clean it up. Okay, so we've got to do those 2 derivatives, and we'll see if there's any algebra we can do on the problem. Okay, so bring down the 1 plus sine x. All right, now, in your head, what is that going to be? What's the derivative of 1? 0. What's the derivative of the sine? Cosine. Okay, so what that's going to be is 0 minus the cosine, so that's going to be negative cosine x is what that is. Okay, now move on to the next part. You got minus here, then you got 1 minus sine x here, and then do the derivative of this. So in your head, what's the derivative of 1? 0. What's the derivative of the sine? Okay, that would be cosine. All right, so that is going to be replaced with cosine of x, like this then. And then I'm going to leave that squared like that. So that's the derivative, okay? That's the calculus. Now what we need to do is see if there's any algebra, see if there's any basic identities or anything that we can work with, okay? And factoring is always kind of a big deal in these problems, so that's what I'm going to go through basically and look at then. Okay, if you look at this problem real carefully, I'm going to go ahead maybe and write one more step because I'm kind of hoping you'll see this a little bit better. So I'm going to put that cosine in front, so I'm going to write that as negative cosine x times 1 plus sine x, and then I'm going to put that cosine in front, like that, and then I'm going to leave this basically alone like this for now. Okay, then we'll kind of see what we can get from there. Okay, now remember there's a lot of factoring that goes on these problems. So what I'm going to do with this now, I'll just keep moving this over this way, is the common factor that comes out. What do you see as a common factor in the numerator? Cosine, that's it. Now 1 plus sine and 1 minus sine are different, aren't they? They're different, so you got to do this. Now factoring is a huge thing in calculus when you're dealing with derivatives. So you're going to take it out, and you could even take a negative cosine out if you wanted to. That's what I'm going to do. You don't have to, though. So I'm going to take negative cosine out, And then watch this carefully. Okay, if I take that out, what you're going to be left with is this thing right here, 1 plus sine x, like that. Now that's going to change that sign because I took a negative out to positive. Then you're going to have 1 minus sine x like this. Now, until you get better with this, you know, anytime that you do any factoring, make sure you did it right. Okay, notice that if I multiplied that by that, doesn't that give you what you started here? Okay, look at that carefully. Now if you do this times this, you have a negative times a positive is a negative, and that gives that. So tell me if that looks okay. Okay, look inside the brackets. What happens? These like terms cancel. That's great. Okay, that makes it easy. And then you got 1 plus 1 is 2. So it looks like what you have is 2 there. And I'm just going to put that 2 that's left over in front of the cosine like that. Then I'm going to leave that alone. Okay? And then this is probably a good enough answer. You could multiply out the bottom if you wanted to, but you don't have to on this problem. There's no benefit in doing that. Does the factoring look okay? Okay? Because like I keep telling you guys, that's what most of the deal is in this class is there's lots and lots of factoring that goes on these problems, and lots of algebra, okay? All right, any questions? Let's go ahead. I'm going to have you, before I do example 2, I am going to do that, but I want you guys to go ahead, go down and do the example below, cosine x, sine x minus 1 with the quotient rule, and work on that for a few minutes. What I'm going to do is I'm just going to erase what I just did. So if you need to get that copied down, go ahead and do that, and then take a few minutes to see if you can get that problem below. Then we'll go back and do that example 2 then, okay? And that's quotient rule is what you're going to be doing on that then.
Can you write the quotient?
It's right here.
Oh, okay.
Yeah. And, you know, in time you'll get to where you know those rules pretty good. You have to kind of do some practice on that, but product rule and quotient rule you're going to use all the time, so you'll get those down pretty quick.
So when it's
keep kind of going through it. So I'm going to go ahead and just get this put in the quotient rule. So again, what we're going to do is we're going to write down the bottom, sine x minus 1. Then you're going to multiply that by the derivative of the top, which is cosine x. And then it's minus the top, cosine x, multiplied by the derivative of the bottom, which is sine x minus 1. And then it's going to be all over the bottom squared like that. So that's step 1. That's usually not the issue. Next thing is the derivative. And this probably won't be an issue. So you got to do that and you got to do that. So if you can get that, then you'll be done with the calculus. Okay? All right, so the next step we should have sine x minus 1. And again, what's the derivative of the cosine? Careful, it's negative sine x, so you've got to be kind of careful about that. So that's negative sine x. It's good to write it in a parenthesis like that. Okay, then we got minus cosine x. And then what's the derivative of the sine x minus 1? Cosine x, okay? Because remember, that's a constant, so that's really 0. So that's just going to be times cosine x like that. Then it's all going to be over bottom squared. Okay, so that would be the end of your calculus right there, but don't leave your answers that way. Crunch it out, go further. All right, so what I see that you can do on this is you can do a distributive property here. So notice you're going to have negative sine times sine is negative sine squared x. Okay, now then what you're going to have is plus sine x there. Okay. Now, what we're going to have here is cosine squared x here, and then all over sine x minus 1 like squared like that. Okay, does that look okay? Yeah? No?
Yep. Yes.
Okay, there's a very, very famous identity that shows up. I hope everybody remembers this one. What's the sine squared x plus cosine squared x? 1. Okay, so if you look at this the right way, it's in there. It's embedded within there. So basically, if you do this, if you group this together, I'm going to group this together like this. I'm going to put together negative sine x minus cosine squared x plus sine x like this. Now, before we use this identity, you got to factor a negative out of there. Okay, so you got to group that together and factor that negative out. So what you're going to have really is negative 1 times sine squared x plus cosine squared x, then plus sine x. I think I left my square off of there. So you have this. All right, now tell me if that looks okay with the algebra, because you a lot of times in this class get into some algebra issues that you might not be that strong at yet. Okay, you can't do that until you factor that negative out. And the way I knew to do that is because I know that identity. Okay, does that look okay? If you got two negatives in something, you can take a negative out. Okay, so now what you're going to do on this is, of course, what's the value of that? That's 1. So that's going to be 1 times negative 1. So that's going to be negative 1. So what you end up having then, and then this problem's got a lot of algebra in it. I'm going to move this over here. So this is now negative 1 plus sine x all over sine x minus 1 squared. And this problem is not done yet. What do you notice about the top and bottom? They're almost the same, okay? All right, so what we're going to do is we're going to rewrite the numerator as sine x minus 1. You can turn that around. You're not changing anything. And then this squaring thing, you don't want to FOIL it out. You can just write it out twice like this. Then what happens? One of them cancels, leaving you 1. So you would get as an answer 1 over sine x minus 1. Okay, and that would be as far as you could take that. Okay. That's a good problem. That's what you get into, is you get into lots and lots of algebraic simplifications on that then. That's the idea. Okay? All right. Let's see. I think what I'm going to go ahead and do next is I'm going to move up to doing the problem that I didn't do a few minutes ago and do that, and then we're going to kind of move on into developing the other trig functions here. So is there any question on the algebra of that? Okay, you guys got the calculus down probably, right? Quotient rule, that's not the issue, but you do have to work with trig identities a lot on these problems. So that's one of the reasons why we try to make our students in trig memorize those identities, because they keep showing up and you can't keep looking for them. You know, they need to be up here, at least the basic ones do. Okay, all right, now let me move up here and let's do this example 2 here. And then this one, what I'm going to do with this one is, to me, the first thing to do on this probably would be to go ahead and just multiply out the numerator. I think it's probably just as easy on that to do it this way. I'm going to erase that little piece right there, and then we'll go ahead and just put this together. Now this is, again, this is a quotient rule problem, but let's go ahead and start this like this. Let's write down, multiply this out, so that's going to be x squared cosine x, and then minus cosine x like that. Okay? Then we're going to leave that alone like this, and then we're going to use the quotient rule. Okay? That would be one way to do it. You don't have to do it that way, but to me it's good just to multiply that out. Okay? Now this is a little messier than the other ones. So when we do the derivative, the first thing that you want to do is you want to go ahead and get this thing set up in the quotient rule. So you're going to take the bottom, which is cosine x plus 1, and you're going to multiply that by the derivative of the top. And this is going to get, unfortunately, a little messy. Okay? So what I'm going to have here is we're going to do, just write down that we're going to do the derivative of x squared cosine x minus cosine x like that. Okay, then we're going to go minus, then we're going to go top, x squared cosine x, and then we're going to multiply that by the derivative of the bottom. Okay, I'm kind of running out of room there, so let's see if I can move that over just a tad bit here. Okay, then that's all going to be over the bottom square. Okay, it's always, to me, very important when you do these quotient rules, product rules, write it down that way. Okay, so again, what I've done is I've done bottom, then I'm going to do derivative of top, minus top, and I think I may have missed something on the top, didn't I? That thing right there actually should have a minus cosine in it, because the top is x squared cosine x minus cosine x times derivative of bottom. Okay, like that. Okay, now we're going to do a couple of derivatives. We're going to do that derivative, and we're going to do that derivative. Then we're going to have a whole bunch of cleaning up to do on a problem like this. Okay, all right. Now, so let's just bring this down. We're going to have cosine x plus 1. Now, when we do this derivative that I highlighted, how are you going to have to do the derivative of x squared cosine x? You have to use the product rule. You got to use product rule, right? There's two things being multiplied. So you have to do the product rule. You have to. So let's go ahead and let's focus just on this thing right here. That's product rule. Okay, so that's going to be the first. And let's do some of this in our head now. So it's the first. What is the derivative of the second, or the cosine? What is that? Negative sine. So write down times negative sine x. Plus the second. Remember, we're just doing this piece right here. That's cosine x. And then what's the derivative of x squared? 2x, right. Okay, I just did a product rule. All right, now we're going to go minus, and then what's the derivative of cosine? Negative sine x. Okay, like that. Okay, have to do it. Sometimes you got to use two rules in the same problem. Now we did a.
That's minus negative sine x?
Yep, because that's a minus that's coming from there, and then the derivative of the cosine's negative sine x. Of course, that's going to make that plus sine x. Now we're going to do the rest of this, so we're going to bring down this minus. Okay, that's going to be x squared cosine x. Now, this one's not too bad. So what's the derivative of cosine x plus 1? Negative sine x. Derivative of cosine is negative sine x. Okay, so we have that. Okay, and then that's going to be all over the bottom squared. Okay, like that. Okay, that's kind of a mess, isn't it? This is what you get into. Like I said, by the end of the semester, you'll be an algebra whiz because it gets complicated, okay? Or messy, I shouldn't say complicated. Just gets a lot of stuff going on in the problem, okay? Now, let's go ahead and clean it up. So I'm going to write down that as a cosine x plus 1. Now, let's look carefully inside of this parenthesis here. And I want to see if you guys see what I see. I see something canceling. Do you see it? Yeah, exactly. Now, if there's something you can do in your head, do it in your head. Because see, right there, that's really a plus, isn't it? So that would be a plus sign minus a sign. So that's going to cross out. Okay, so you can do that. Now let's write what we're left with. What we're left with is x squared. Whoa, hold on. You can't do that.
Yeah.
What in the world am I thinking? You know why you can't do that? Because that's multiplied right there. Okay, you can't do that. I was looking at it the wrong way, so you got to be careful about stuff like that. See, that's addition, but then this is multiplied by that. So let's clean it up. Let's write this as this piece right here. Write that as negative x squared sine x. Then write this piece right here as plus 2x cosine x. And now write that as plus sine x, like that. Now when you go to this piece over here, notice you have a negative times a negative, so that's a positive. Then you have x squared cosine x sine x, like that. Okay, then it's going to be all over the bottom squared, like that. Okay? Now what we'd have to do on a problem like this is just basically see if there's any kind of multiplication or any kind of factoring we can do on this. I don't really see any factoring we could do, but you could do a bunch of multiplication, okay, to do that.
Isn't that sine x supposed to be minus cosine x?
Which part are you looking at?
Right there.
Right here?
Yeah.
Now that became from here, that was minus, because we did minus the derivative of the cosine, so that became plus sine x.
Okay.
Okay? Because that came from minus the derivative of the cosine, like that. Okay? All right, let's do one more thing with this. Okay? Now, we're going to multiply this out. And students always say, do I have to go this far? And my answer is always yes. Okay, do you have something?
Oh, never mind.
Okay, you okay? All right. Yeah, you got to take this as far out as possible. Okay, so I'm going to multiply out what I just highlighted. Okay, so we're going to do this carefully now. We're going to do this times this. So that's going to be negative x squared, and I'm going to write that as sine x cosine x. Doesn't matter what order you put that in, of course. Then I'm going to do this times this. So that's going to be plus 2x. Cosine times cosine is cosine squared x, like that. Okay, then I'm going to do cosine times sine x. So I'm doing cosine times sine. It's going to be that. Okay, so I've got that now. Now I'm going to multiply everything by 1, which is nice. It's easy to multiply something by 1. Everything's just going to be itself. So when you do 1 times this, that's minus x squared sine x. And then 1 times this is going to be plus 2x cosine x. And then 1 times sine x is going to be sine x, like that. And that'll take care of that multiplication. See, I've done 1, 2, 3, 4, 5, 6 multiplications. Okay. Then this thing will come down. So I get x squared cosine x sine x, like this. Now it's all over the bottom squared, and what we're going to do is see if there's any cancellation, see if there's any like terms or anything that we can put together. And then this may be an example of something that there's not going to be very much to do. So let's see if we see anything that might cancel. You see anything that might cancel? There's something there I think I saw. Yeah, so I think I see one cancellation there for sure. Okay, so this and that are the same, aren't they? So they cancel. Is there anything else? Let's see. I don't really see anything else there. I don't see any like terms. So I think that's probably it. I don't see anything. What's that? No, I think they're all different. 2x. See, this is a 2x cosine squared x. That's a 2x cosine x. So everything's different. Okay. All right. So let's just write it, and then we'll just take that as an answer. 2 cosine squared x plus cosine x sine x minus x squared sine x plus 2x cosine x all over cosine x plus 1 to the second. Okay, like that. There may be a little bit more factoring and stuff you can do on that, but that seems to be it. Okay, what do you think of that problem? You don't like it. You think it sucks, right?
We needed more room on our keyboard.
What's that?
We needed more room.
I know. I didn't think about that when I did that. That's not anything you'd be tested over. That's, not even probably that good of a homework problem. But that one it's an exercise in algebra more than it is anything else then, okay? All right, well, I'm going to go ahead and pause here. I'm going to have you do what I think is a pretty simple short quiz that you can work on. That's doing